Okay, so on this video, we are going to go from finding the volume of a regularly shaped object, such as this, which has a formula, to the volume of an irregularly shaped object, such as something like this. So first, the definition of volume is anything that takes up space. So most things in this world are not taking up space in this kind of form, in what we call a regularly shaped object. So you guys are experts at doing this so far, and you just plug things into a simple equation. So this is 8 times 8 times 1.5. So when I do my calculations, it gives me that this block is 96 centimeters cubed. Because remember, we're measuring space, which means we're measuring it in 3 dimensions. So what that really means is that I can fit 96 of these in this object. And what is this? This is a 1 by 1 by 1 centimeter cubed. Exactly. Okay, so here's another example of it. So this would be an 8 centimeter cube, because this is 2 by 2 and by 2. All right, so the key to understanding how to do an irregular shaped object is this right here. What this shows us is that 1 centimeter cubed is exactly equal to the same amount of space that 1 milliliter is. So with that being said, if I were to melt this down and pour it into this graduated cylinder, it would come up to exactly here. 1 milliliter is a centimeter cubed. If I were to melt this down, which is 2 by 2 by 2, 8 centimeters cubed, it would come up to exactly here. Okay, so if I poured this in, it would go up to 8 centimeters cubed. And if this were made of plastic and not wood, and I could melt this down, it would come up to exactly 96 milliliters here. So 1 milliliter is a centimeter cubed when it comes to volume. And that's what's nice about the metric system, because we just connected length to volume of solids with centimeters cubed, and then we did the same thing with liquids, and we're on to our next base unit, which is liters. Okay, so we're dealing with thousandths of a liter. All right, so let's get the hang of displacement. Displacement means when you move something into a situation, something has to move out. So everybody here is taking a bath at one point in your life. When you get into the bathtub, the level of the bathtub, it rises, right? Okay, what you did was you displaced water. Another example might be if I were to have 20 seats in my classroom and 5 kids came in, that would mean that 5 kids would be displaced. They would have to move to another room. Okay, so displacement means to move out of your way. All right, so let's learn how to use the graduated cylinder when it comes to displacement. Okay, so here is a graduated cylinder. It's a 50 milliliter graduated cylinder, and I'm going to use it to measure the volume of this bolt, an irregularly shaped object. Okay, so the first thing I want to do when I get back to the lab is I want to make sure that this thing fits in and it's not going to get stuck. All right, so it fits in. The other thing that you want to do is you want to use the smallest graduated cylinder that you can. For instance, I would never use a 500 milliliter graduated cylinder to measure this, because when you put it into water, the water is not going to come up very much. It would be like the equivalent of you getting into the main end well pool. You're not going to see the water of the pool move up, okay, because the total volume is just too much. So use the smallest graduated cylinder possible for the job. All right, so this is how it works. The first thing that you're going to want to do is you're going to want to put a beginning amount of liquid in. Okay. And then measure that beginning amount of liquid. We call this the initial amount. So when I look at that, it measures at the bottom of the meniscus 23 milliliters. So I'm just going to write that down. 23 milliliters. Now the next thing I'm going to do is I'm going to put my object in. Okay, so I want to get the volume of this bolt right here. When I get the volume of this bolt, or when I put it in, I need to be careful because I don't want to just plunk it in, because if water splashes out, then we get an inaccurate measurement. The other thing you want to make sure of when you do this is, because sometimes we're going to have glass, you want to put this in at an angle. So you very carefully slide it down in so it doesn't break the bottom of the container, and you do not spill any liquid out. All right, so if we remember what our beginning measurement was, it was 23. And you will have written that down in a data table when it comes to the lab. Now our final measurement here is 30. That means that the volume of this bolt is 7. So we had an initial measurement of 23 and a final measurement of 30. When you look at a data table, I always write my initial measurement on the bottom, and then I write my final measurement on the top. So all I have to do is do a quick calculation, and this is going to be 7 milliliters. Okay, now, could I write, instead of saying that the volume of it is 7 milliliters, could I say that it's 7 centimeters cubed? Absolutely. In fact, when we deal with things that are solid, we usually say centimeters cubed. And when we deal with things that are liquid, we usually use the unit milliliters. But remember, it's the exact same thing. Let's do one more. All right, so let's do something a little bit smaller. Okay, so I'm going to do this. So when I do this screw here, I need to fill this up with liquid to a volume that's appropriate. I want to make sure that it's enough to cover it when I put this in, but I don't want it to be too much because I don't want it to go over the 10 mark either. So I'll put in just enough to start. Okay, so I know that this is going to cover it, so I think I'm safe. And I don't think this is going to be any more that's going to push it up over the 10 mark. All right, so again, put it in an angle, make sure it goes all the way in. It's not too big where it's going to get stuck. And I just realized that I forgot to do something, you guys, because I'm talking. I forgot to get an initial measurement. It happens. Okay. Initial measurement is 4.2. Okay, so I'm going to write my initial measurement down. Whoop, I got to make sure. 4.2, 4. No, this is 4.4. Okay, 4.4 is written down. Now, go ahead and put my object in. And now I am up to 5.8. Okay, I'm going to write it down on my sketch, 5.8. So now all I have to do is make my calculation. So the volume of that screw was 1.4 centimeters cubed, or 1.4 milliliters. Now, the last way that we can take the volume of something using this process of displacement would be something called an overflow can. So an overflow can looks like this, and I've already filled it up with water right to the top. And I have a bucket down below me to catch water. You guys will do this over the sink. All right, so the first thing you do is make sure that the overflow can is filled up to the top and it's drained. Now at this point, the most immature kids in the class will laugh and giggle, and you know who they are. You can point to them right now. And you want to make sure that it's done doing that. All right, so what we're going to measure in this case is we're going to measure this big stopper. This could be a rock or something that's just not going to fit into even one of our biggest overflow containers. All right, now I'm going to choose my graduated cylinder. I'll choose this 100 milliliter one because I think this would be the best for the job. So one person, or you can do this with two hands if you want, one person is going to hold it under the spout and one person is going to gently lower this into the overflow container. And be careful because you have to go slowly with it. You don't want it to overflow over the top of the container. And then when your fingertips hit it, you got to let it go because you don't want to get the volume of your fingertips. And then that will go until it's done dripping. And then you would put this down on a flat surface and you would read it, and that will be the volume of whatever you put into your overflow container. Get back to the lab and get to the items and have fun using graduated cylinders and overflow containers.